guys, I'm Azad. Thanks for watching me. Today I'm gonna get the derivative of inverse trigonometric functions. So I continue differentiation rules with ninth rule. As you see, arc sine x equals inverse sine x. And arc cosine x equals inverse cosine x. It's also for tangent and cotangent. How to get the derivative of arc sine u? For getting the derivative of arc sine u, first you should get the derivative of u. U is a function of x. So for up, it's u prime, and for down, it's square root of 1 minus u squared. For getting the derivative of arc cosine u, like before, first you should get the derivative of u. It's u prime. But be careful, there is negative here. And for down, it's square root of 1 minus u squared. For getting the derivative of arc tangent u, first you should get the derivative of u. The derivative of u is u prime. For down, you should write 1 plus u squared. For getting the derivative of arc cotangent u, first you should get the derivative of u. It's u prime, but negative u prime. And for down, you should write 1 plus u squared. Okay guys, in this example, according to the formula for up, this term is u. So the derivative of u is 1. And for down, you should write a square root of 1 minus u squared. It's x squared. For getting the derivative of arc tangent x, according to the formula for up, there is u prime. This term is u. The derivative of x is 1. So 1 is for up, and for down, you should write 1 plus u squared, x squared. Next example. Okay guys, in this example, we should get the derivative of arc cotangent. This term is u. According to the rule, for up, there is negative u prime. As you see, u is a radical function. I explained how to get the derivative of radical functions in another video, which is radical functions differentiation. So according to the rule, m is 3 and n is 1. For up, it's n1 times u prime. Now you should get the derivative of this term. As you see, two terms sum each other. So you should get the derivative 1 by 1. The derivative of x is 1. The derivative of 2, as the 2 has a constant value, so the derivative of it is 0. For down, you should put 3 times 3 again, x plus 2, for the power you should put m minus n. It's 3 minus 1. And for down you should put 1 plus u squared. X plus 2 to the 2. Okay guys, in this example we should get the derivative of inverse tangent sine 2x. This term is u. According to the formula for up, it's u prime. For getting the derivative of u, first you should get the derivative of this term. The derivative of this term is the coefficient 2 times. No, you should get the derivative of sine. The derivative of sine is cosine. And for down, you should put 1 plus u squared. Sine 2x squared. Next example. Okay guys, in this example, according to the power rule, first you should bring the power down. It's 4 times. Now you should get the derivative of this term. According to the formula, for up, there is negative u prime. This term is u. So the derivative of u is the coefficient 3. It's negative 3. And for down, you should put a square root of 1 minus u squared. It's 3x squared. It will be 9x squared times. No, you should reduce the power by 1. It's arc cosine 3x to the 3. Next problem. Okay guys, for getting the derivative of this function, we should use quotient rule. I explained product rule and quotient rule in another video, which is differentiation rules part 1. So according to the quotient rule, first we should get the derivative of up. It's two x times this term, arc tangent 3x. Now you should get the derivative of this term. For getting the derivative of this term, first you should get the derivative of u. So according to the formula, for up there is u prime. It's 3. And for down, you should put 1 plus u squared. 3x squared, it's 9x squared. Times this term, x squared. Now, you should repeat this term, arc, tangent, 3x to the 2. Next problem. Okay guys, in this example, as you see, two functions multiply each other. So there is product rule here. According to the product rule, first you should get the derivative of this term. For getting the derivative of this term, according to the power rule, first you should bring the power down, then reduce the power by 1. It's 2x times this term. Inverse cotangent square root of x plus, no, you should get the derivative of this term. For getting the derivative of this term, it's u. So according to the formula, for up, there is negative u prime. As you see, u is a radical function. So according to the rule, for up, you should write the derivative of x. As the power is 1, so the coefficient is the derivative. 1. And for down, you should put 2 times square root of x. Now, you should write 1 plus u squared. As u is square root of x, then raised to the 2 in the end, it's just x. Times this term. Times x2. Next problem. Okay guys, in this example, for getting the derivative of this trigonometric function, first you should get the derivative of this term. For up, there is u prime. This term is u. According to the power rule, first bring the power down and times in the coefficient and put it next to the x. It's 2 pi. No, reduce the power by 1. It's x. And for down, you should write 1 plus u squared pi x squared to the 2. No, you should get the derivative of sine. The derivative of sine is cosine. Repeat this term. Arc, tangent, pi x squared. Next example. Okay guys, for getting the derivative of this trigonometric function, according to the power rule, first you should bring the power down. It's 3 times. No, you should get the derivative of this term. As this term is inverse trigonometric function, so according to the formula, 2x is u. So for the up, there is negative u prime. Negative u prime is 2. Because power is 1, just the coefficient is the derivative. It's 2. And for down, it's 1 plus u squared. 2x squared. It's 4x squared. Times. No, you should get the derivative of cosine. The derivative of cosine is negative sign. Now repeat this term. In the end, you should reduce the power by 1. It's cosine squared. Repeat this term. Okay guys, how to get the derivative of this trigonometric function? There is a trigonometric formula which says secant x equals 1 over cosine x. According to this formula, we can replace 1 over cosine x instead of secant in this function. So it will be d over dx one over cosine arctangent x. Here there is quotient rule. So according to the quotient rule, we should write, first we should get the derivative of 1. The derivative of 1, as 1 has a constant value, is 0. Minus. No, we should get the derivative of this term. For getting the derivative of this term, first we should get the derivative of arctangent x. The derivative of arctangent x, according to the formula, it's 1 over 1 plus u squared. U is x. It's x squared. No, you should get the derivative of cosine. The derivative of cosine is negative sign. So it's times negative sign. Repeat this term. Arc tangent x. And for down, repeat this term to the 2. It's cosine arctangent x to the 2. Okay guys, take care. Bye.